Hello, my dear mechanical and civil champions. This is Chandrasekhar welcoming you all to this daily dose series for civil and mechanical engineers. As you all know, that in this series we bring an important concept or sometimes a question to make the concept very simple and clear for you. So in today's session, I will be talking about the fluid mechanics. I will be going to discuss one of the most important concept of fluid mechanics, that is the concept of buoyancy and Archimedes principle. Actually, I will be discussing a very beautiful interview question. You can find this type of question in your interviews, which is related to the buoyancy and Archimedes principle. All right. But before I start, let me quickly introduce myself. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in the field of GATE, ESE and PSUs. So with my experience, knowledge, qualification, I will try to make the understanding of buoyancy as simple as possible for you through this numerical, it is not a numerical, through this conceptual theoretical question. All right. So the question I am having today says, a person is sitting in a boat which is floating in a small pond, and if the person throws an anchor into the pond which sinks at the bottom of the pond, then what will happen to the level of water in the pond? Will it rise, will it fall, or will there be no change? So actually, if you see the questions, there are two situations here. One is when the anchor is still in the boat along with the person, and the second case is the anchor is thrown into the pond which sinks to the bottom. So in both the two situations, what we will do is we will try to find out the volume of water displaced, and by comparing the volume of water displaced, we will find out whether the volume of water or whether the level of water in the pond will rise, fall, or will there be no change. All right. So let us start with the first situation, when the boat is having the person and the anchor. So boat plus person plus anchor will be in vertical equilibrium. What is the condition for vertical equilibrium? Net vertical force must be 0, isn't it? So there are two forces acting on the boat. One is the total weight, which is acting in downward direction. Total weight is acting in downward direction, isn't it? Can you see it here? The total weight is acting in downward direction. And the another one is, the total weight is acting in downward direction, and the next one is the buoyant force, which is acting in upward direction, buoyant force by water. So both the forces are acting in vertical direction. So for the first case, when the anchor is inside the boat, is in the boat, then we can say the buoyant force exerted by water should be equal to total weight. What is the meaning of total weight? Total weight is the weight of the boat plus weight of the person plus weight of the anchor, isn't it? B for boat, P for person, A for anchor, and buoyant force by water is equal to density of water into volume of water displaced into G. So that is the expression for vertical equilibrium. So can we find out the volume of water displaced? Volume of water displaced is equal to weight of the boat plus weight of the person plus weight of anchor upon density of water into G. Do you understand? Do you agree? Here B represents the boat, P represents the person inside the boat, and A represents the anchor which is still in the boat. right? Or we can write it as volume of water displaced in the first situation. Can we write this volume of water displaced in the first case as volume of water displaced can be written as weight of the boat plus weight of the person divided by density of water into G plus weight of anchor divided by density of water into G. What is the weight of anchor? Can we write it as the volume of water displaced in the first case will be WB, weight of the boat, plus WP upon density of water into G, plus can we write it as density of anchor into total volume of anchor, that is the mass of anchor, into G upon density of water into G. This is the volume of water displaced in the first situation. That is the volume of water displaced by the boat plus anchor plus the person displaced in the first case. This is equation number 1. Now, the second situation is when the anchor is thrown into the pond. Then what will happen? Then again, boat and person will be in vertical equilibrium, isn't it? So the boat and person will be in vertical equilibrium. Here only boat plus person is there. Boat plus person. Now they are in vertical equilibrium. Anchor is thrown into the pond. Second case, anchor is thrown into the pond. Then for vertical equilibrium for boat plus person, the total weight of boat plus person, weight of boat plus weight of person is acting in downward direction, and the buoyant force will be acting in upward direction. Isn't it? The buoyant force will be acting in upward direction. Buoyant force by water. So when anchor is thrown into the pond, then for vertical equilibrium we can say net vertical force must be 0. Or we can say buoyant force by water is equal to weight of the boat plus weight of person, because it in the boat plus person is in vertical equilibrium. So density of water into G into volume of water displaced is equal to weight of the boat plus weight of person. So volume of water displaced because of the vertical equilibrium of boat and the person, volume of water displaced is weight of the boat plus weight of the person upon density of water into G. That is first thing. But as soon as anchor sinks to the bottom of the pond, the anchor will also displace some water. And according to Archimedes principle, do you know what is Archimedes principle? The fluid displaced, the volume of the fluid displaced or the weight of the fluid displaced is equal to is corresponding to the volume of the fluid displaced. Weight of water displaced is equal to, according to Archimedes principle, weight of water displaced will be corresponding to volume of body inside the fluid. So when anchor sinks to the bottom, then weight of water displaced is the buoyant force. Buoyant force by water on the anchor is equal to density of water into volume of anchor into G, isn't it? That is the buoyant force by water. So can we call it as, what is the buoyant force of water? Density of water into G into volume of water displaced is equal to density of water into volume of anchor into G. Are you getting it? So what is the volume of water displaced? Volume of water displaced in when the anchor, volume of the water displaced due to anchor sinks to the bottom is given by density of water into volume of anchor into G upon density of water into G. So these two will be the total volume of water displaced. The volume of water displaced is due to the vertical equilibrium of boat and person, and there is a volume of water displaced due to the anchor sinking to the bottom. So can we say in the second case, the total volume of water displaced is equal to volume of water displaced due to the vertical equilibrium plus volume of water displaced due to anchor sinking to the bottom, isn't it? If we put these values, so volume of water displaced in the second case will be weight of the boat plus weight of person upon density of water into G, that is this parameter, plus density of water into volume of anchor into G upon density of water into G. This is the parameter, this one. So if you compare these two, this is the volume of water displaced in the second case. Water displaced in the second case. So if we compare first and second, the difference is here. The difference is here. If we compare the first expression, what was the first expression? This was our first expression. This was our first expression. So let me write it again. If I write it again, so volume of water displaced in the first case when the anchor is still in the on the boat, then it is weight of the boat plus weight of person upon row of water into G plus density of anchor, volume of anchor into G upon density of water into G. And what is the volume of water displaced in the second case? There are two situations where the volume of water displaced will take place. One is due to vertical equilibrium for boat and person. So that is weight of boat plus weight of person divided by density of water into G, plus the sinking anchor will also displace some water corresponding to its volume. So density of water into volume of anchor into G upon density of water into G. If you compare these two, then we can comfortably say density of anchor is, or density of water is less than density of anchor. Anchor is metal and water is having lesser density than anchor. So do you agree volume of water displaced in the second case will be less than volume of water displaced in the first case? Because less volume of water is displaced when the anchor sinks to the bottom compared to the earlier case when the anchor is still on the boat, then we can say the level of the water will fall. The level of water will fall in the pond. I hope you have understood it. You have enjoyed this concept. So that is all from my side. See you in the next such video. Till then, enjoy, take care, have a good day and a great career ahead. Jai Hind.